Hi, Katie. Hi, Katie. How are you doing? Hello? Hi, Max. How are you doing?
Good, good. How are you?
Good, good, good. I think Katie is connecting her audio. So let's start first. So any questions?
Yeah, I've just got a couple more questions.
Yep.
Um, so first one, in non-linear discrete systems,
Yep.
when we're asked to do linearization,
Yep.
does that mean so I've noticed in a lot of examples it only just finds the A matrix and B matrix.
Yep.
Does is what it when it asks for linearization, is it asking for the general solution, or is it just asking for the A matrix or B matrix?
I think it's general solution. So if you have your output y function, which is sorry, I'm getting someone here. So the general formulation is xk plus 1 is equal to ax plus bu, right? And then the output y is cx plus bu. So if in the question there is an output function, then you have to linearize the output function as well.
Okay.
But if there's no that function, then you don't have to do that.
Right.
Yeah. So it's suppose you have a nonlinear discrete time system, and you only have the xk plus 1 is f xk plus uk. And you don't have the output y function. Then you just need to calculate a and b, and that's fine.
Right. Okay. Okay.
Yeah. That's a good question.
So I don't. So just to clarify, I don't have to put it in like the form where it's like xk equals a to the power of k x naught plus like the discrete system general solution. It's just find a, b, and maybe c and d.
It's finding a b or a b c and d, then write it into the general formulation. You have a b c and d, and then can write it in, right? And also so when you write it in, sorry, I think it's a little bit delayed. So and also when you write it, you need to know that it is delta x and delta u instead of the original accent.
Yeah. So do it like that. Do it in like the general form, not the solution general form. I think I get what you're saying.
So if you have a, sorry, what do you mean by solution general form?
Well, I guess it doesn't make sense what I'm saying, because it's a approximation of a particular area, like particular point. So what I'm trying to do is look at the discrete system and go, if it's in a discrete system, it must be.
Mm-hmm.
Anyway, I think I understand what you're saying. So
cool. Yeah, cool. That's great. Yeah.
Another nonlinear question I've got is I just don't quite understand how, or so if a system has several equilibrium points, one of those points might be stable, one of them might be unstable.
Yeah.
Does that mean that the whole system is unstable, or is it just at those points that it's stable or unstable?
Just those points. So that, I think that's a very good question. So for the nonlinear system, it is so complicated that you can assess the stability of the complete system. So what we can do is we can only assess the stability at the equilibrium point.
Okay.
Yeah. So I think I give example during the during the lectures. So for us, because equilibrium point is some kind of like if you I mean, the state will stay at that value forever, right? But what does it mean for a unstable equilibrium point? A good example is the inverse pendulum. It is stable, but with a very small move, then it will like diverge. It will not converge.
Yeah.
So that is a good example about the unstable equilibrium point. Yes, you are right. So the equilibrium, so the stability can only be assessed at the equilibrium point. Yeah.
Cool.
Yeah.
I've got 2 more questions. Is that okay, or do you want to go?
Yeah, go ahead. Go ahead. Yeah.
Okay. So I just want to know about visual surveying.
Yeah.
I'm trying to work out. So I've got that MATLAB script from the lecture.
Yeah.
I'm trying to work out what kind of things I might have to write down if I get a question like that in the.
It's a good question. It's a good question. Yeah. Yeah.
So what? Yeah. Does that? Yeah.
Yeah. So I think if you have a question asking the visual surveying, do some kind of visual surveying, and also I think in this semester, because you can use MATLAB, then if there is a question about visual surveying, I may ask you to do some calculation on that as well, because it's easy for you to do that, right? Before you can't do that, you can't calculating the pseudo inverse, but now you can. So what I'm expecting the student to write if there's a question is, you first write the ideas about how to do this visual surveying, and also the progress with necessary equations. All right, so that's the first thing. The second thing is to do some calculations of the necessary variables in the visual surveying. So can I ask you what are the necessary variables you're calculating during the visual survey?
So I think the goal is to get well, it's like the velocity of the camera, like or linear velocity and rotational velocity. If it's on the end effector anyway.
Yeah.
And there's like the L, like that.
Yes.
There, and the error is probably an important one as well.
Yeah, that's great. That's a great answer. So if you write it, if you write the answer for that question, so first, as I mentioned, first write the idea and also the process about solving it with necessary equations, and then calculate the values of the necessary variables, as you mentioned, the error E, right, and also the Fisher-Jacobian L, and also the pseudo inverse of L, right? And after you have those numbers, you can do this calculation in MATLAB, but write the numbers into the exam paper, something like that. And then after you have those values, then you can calculate the camera velocity, right? And also put your answer, I mean the numbers of the camera velocity you calculated into the exam paper as well. I mean, you can do this kind of calculation in MATLAB, write down the answers onto the paper. So what I mean is write it as a like long answer question with calculation, and then do the write the necessary equations and the calculations of the necessary variables and get your answers as well. But when doing calculations, you can use the MATLAB.
Okay.
Yeah.
Cool. So just the process would be putting down the equation for the error, putting down the equation for the Fisher-Jacobian, and then calculating the velocity, like the equation to calculate the camera velocity, and then just going down and filling out each of those equations.
Yeah.
Okay, great. Yeah. And last question, and you probably won't be able to answer this, I imagine, but so like for example, in the first kind of control lecture, that you've got a bunch of examples, like real world examples.
Yeah.
And like a particularly complicated one that of the inverse pendulum. I guess what I'm asking is, do I need to know how I guess the 2x2 matrices ones are kind of easier to get the information from, but the inverse pendulum is a bit trickier. So I'm a bit worried by is that I'm going to get a really complicated system that I don't know how to extract the A and B matrix for to do any analysis on. Do you know what I mean?
Yeah. I think I understand what you mean. I think that's a good question. I do suggest you to go through all the examples about this, about formulating the real real problem into the control system. Go through all the examples and also the activities.
Okay.
I think it's we have the some of examples in the linear continuous one, and also a couple in the linear discrete one, right? Go through them. You may be asking some questions about that, about formulating the real problem into the control system, and then answering other questions based on that. I'm saying you may. I'm not saying you have, but it is always good that you practice on it.
Yeah.
I do suggest you practice on all the examples we have in the lectures, and then to see if it's possible, if it's possible for you to formulate it.
And like you said yesterday, if for some reason I can't formulate it, I'll just write down an A and B matrix and then do the rest.
Yeah. So assume you have an A and B, and give the numbers by yourself.
Okay.
Yeah, and then you write down the answers after.
Cool.
Don't make the questions blank. Yeah. Write some information in, and then I can give the marks. Cool. I mean, I think you're aiming for like answering all the questions. Okay. So it will not be that complicated, but it may be like it may be have dimensions more than 3.
Yeah.
Something like that. Yeah, because because you can do some calculations by using method, but I'm thinking if you have this kind of question, then it's not that kind of like difficult for you to formulate.
Okay.
But you just need to practice about this kind of formulation.
Cool. I'll go have a look at them.
Yeah. I do suggest you go and have a look and practice on the examples we have.
Cool. Yeah. All right. Thank you very much.
No worries. So you don't have to wait here. So I'm doing the record. Then I can upload the video to the UTS online. Then you can have a look after.
Awesome. Thank you.
No worries. See you, Max.
See you later. Bye.
See you. Yeah. Hi, Katie. Is the audio right now? Hi, Katie. Hello, Kate. Yeah, then we move to Con. Hi, Conan.
Hi, Liang.
Hi, how are you doing?
Yeah, okay. Yourself?
Yeah, good. Yeah.
Yeah, I was just interested in hearing some of it, other people's questions and answers as well. I was going to ask you about camera convolutions.
Yeah.
I guess should we be prepared to do? I was wondering whether we should be prepared to do like an edge detection kernel on a really large matrix, like whether we would need to like type something larger into MATLAB, or whether it would be something more like
I can't say too much. I can't say too much. Yeah. So there are only 2 or 3 questions because only 30%. So I can't put too many topics in it. So that's why I can't like telling you that which topic will be involved in. But yeah, that's a good question. So I'm not giving too much, too large matrices if there's a question about convolution. It will not be too large. It will not be. It's still like reasonably you can calculate.
Okay, that's good news.
Yeah, and you can do this kind of calculation in MATLAB and write it also back into the paper, the exam paper, and that is totally fine. But what I mean is, it will not be that kind of large. It will not be like a 640 by 480 image. It will not be like that.
Okay, yeah. Okay, that's good news.
Yeah. So, any other questions?
Maybe on just on the concept of ransack.
Uh-huh.
I just want to double check that that's like, is that using a second? That's using a second camera, right? Not, or is it using a second like a could you use a previous image as well, like from the same camera, or do you need two cameras for that method?
That would be similar. That would be similar. So what I mean is, at least you need two images.
Okay, just two images, not necessarily two cameras.
Yeah, two images. Then, so the purpose of using ransack is to delete outliers of the matches. I mean, the wrong matches. The wrong matches means you have like two images and you extract the features and do some matching. And then there will be like some wrong matches. We call it outlier. And we want to delete those kind of outlier. So it's not necessarily be like from the same camera or different cameras, but at least you need to have two images and you need to have the matches. And you want to delete the wrong ones. Yeah.
Okay. Thanks.
Yeah. No worries. Any other questions?
No, not at the moment.
Okay, so you don't have to wait here. I'm doing the recording.
Okay.
I'm doing the recording. You don't have to wait here. Then I'm doing the recording, and then I'm going to upload this video to the UTS Online. Then you can like have a look at the video a bit later.
Okay. Thanks, Liang.
No worries. No worries. All right. See you.
Bye.
See you. Hi, Anthony. Hey, Anthony.
Hi. Yeah.
How are you doing?
I'm doing okay. Thanks. How are you?
Yeah, good. I got your email. I gave you a reply a bit late last night.
Yeah. Yeah. Thanks. I saw that. I was able to figure that out. It just took me a bit longer than I would have hoped, because I didn't have the working out before the final answers.
Mm-hmm.
But one of my questions, first of all, is I think it was one of the slides. I think it was for continuous time systems. It had stuff to do with like inverted pendulum and pendulum stuff like that. Will we need to know stuff like that sort of thing for the like that sort of example for the exam? Because that was only really done in like the MATLAB stuff, as far as I could tell.
Okay, so apart from the inverse pendulum, we still have a lot of examples about formulating the real world questions into the control system, right? So we have a couple of examples in the linear continuous time system, and we also have a couple of examples in the linear discrete time system. All right, so try to practice on that. We may have questions to ask you to formulate real problems into the control system. We may. I can't say yes or no, but we may have that kind of question.
Yeah. Okay. So are all of the questions calculations, or some of them like theoretical responses? So I know there are multiple questions, sub questions, that you mentioned earlier in the semester, but are some of them like theoretical short answer rather than just calculations?
Sorry, what do you mean by saying theoretical like short answers?
Like not solving a question, like
yeah.
theoretical explanations or something like that.
Yeah. You're right. So we will have both. We will have both. So we will have short answer questions, which means it's not required you to do any calculation, but you need to explain something about how to do it. So you write down the idea about how to solve it and the necessary equations and the process about how to solving it, and that's fine. You don't have to do any calculation. But we do have that kind of questions. That belongs to the short answer questions, and we also have long answer questions, which means you need to write the progress about the process about solving questions, and also do some calculations as well. So we do have both.
Okay. Are you able to give like a example sort of thing? Example questions, not anything like the exam, so we get an idea of what kind of question it could be.
I redesigned this final exam a lot. So that's why we don't have like any example questions at the moment. But I do suggest you to consider quiz 1, quiz 2, and also all the activities and examples in the lectures as the examples. Practice on them. Do practice on them, and it will definitely help. And another thing is when you go back to the lectures, then have something in mind that I can't put any experiments in it. For example, I cannot let you to log some data from, for example, laser scanner or something. This cannot be done because it's a final exam. It only contains short answer questions, long answer questions, including calculation. All right. Yeah, so I think when you go through this kind of examples, and then you have a better feeling about which part it can be included in the final exam and which part it can't.
Okay. Also, I had a question regarding the use of MATLAB, because you said we can use it for like calculations.
Yep.
But if we use it, what will we have to write in our paper for our solutions? Because I know you can't just use MATLAB and just go straight to the solutions, but like what would, if we're using it, what sort of stuff are we expected to put in our solutions if we use it?
Yeah, that's a good question. So let me give an example about doing the projections from a 3D point to the image. All right. So what you can do is you can write the necessary equations. Right. For example, if you are using homogeneous points and you are using the matrix formulation, then you can write the necessary equations there, and then you can write the necessary numbers on there as well on that equation. That is before doing any calculations, and then you can do the calculation in the MATLAB and get back the answer to the paper as well, right? So please don't copy any MATLAB codes onto your exam paper. So write down the necessary equations and only use the MATLAB to do some calculations and to write the number back.
Okay, so if I wanted to use the function to get the eigenvalues or the determinant, would I need to show the full hand calculations and use
for the eigenvalues, you directly get eigenvalues.
So I could just write down the
eigenvalue. Yeah, the eigenvalue is just a calculation. Yeah, just for eigenvalue, you just use the MATLAB function to calculate the eigenvalue.
Okay, and same with determinant. I don't need to go through the whole manual process.
For eigenvalues, you don't have to. You just need to calculate the eigenvalues and put the numbers back. That is totally fine. But for some other complicated cases, you need to write down the equations into it, as what I mentioned for the projection.
Okay. Okay, I just had one more question. I'm just trying to find it. I think it was on LQ. I think it was LQR or something. That what the topic was called.
It's the optimal control, right?
I think so.
Yep.
Are we expected to know that for the exam? Because I'm pretty sure all the examples we have for that are using MATLAB.
Okay. So I think that's a good question. So you have when you do this kind of review on the past like lectures, keep the questions in mind. So for which part it can be what kind of question. So I'm asking you. So if I'm having this nonlinear, no, sorry, this optimal control into the final exam, what kind of like questions it can be?
Okay.
Yeah, think about that. So it can be short answer questions, right?
Yeah.
Which is what you mentioned before. So just write the theoretical concepts that you mentioned. You can write down the process about how to solve that question, how to do the optimal control to solve that question, step by step,
Oh,
without
okay. So questions like that.
without doing any calculations, right? And it can also be the calculations because you can use MATLAB. So
Okay.
it can be both. It can be both. But if I'm asking you about if I'm asking you about the question but without any calculation, you need to write down the necessary steps about how to do this kind of optimal control, right? But if I'm asking it as a long answer question with calculations, you need to write down the steps, the process about solving the question, and also with the necessary calculations from MATLAB as well.
Okay, but like with the stuff like with the LQR, I'm pretty sure all the questions that we've been given are using just MATLAB. So with something like that, so we could get like the short answer response using theory, we explain it, all that stuff. But if it was like calculations, but
Yep.
everything that we've been given is using MATLAB code,
Yep.
are we still expected to be able to solve that sort of thing? Because it's all in MATLAB code,
Okay.
like from the
So,
tutorials.
Yep. Let me.
Like
Okay.
there's no
So
hand.
what I mean is, so what's the difference between a short answer question and a calculation of that question? You need to do some calculation, right? So the process is like exactly the same, and the equations is exactly the same, right? You just need to write the process about solving the questions with necessary equations in it, similar as what you have for the short answer questions. And then when you do the calculations, you can get help from the MATLAB, and that's it. Exactly.
Okay.
I can't say it will be if there will be questions on that or not. I can't say if it will be if there will be short or long answer questions. I can't say that, but I'm telling you how to answer the questions if it is there, if there's a short answer question or if there's a long answer question.
Okay. Also, one more question I just thought of. It's not related to this, but are we going to get our marks back for the group project at all before the exam?
Yes, I think I mentioned that before, and also to quite a lot of students. I do because in this year we changed the marks from 30 to 50 on the group projects, and I do think some of the students they have passed this subject after they finished the group project. I don't want the students to which they passed the project already, but they don't want to perform quite well in the final exam. So that's why I didn't release the marks on the group projects. But I will definitely release the marks after as soon as you take the final exam.
Okay, because because like I can understand that, but I would argue like because I didn't do very well on my second quiz, so like without group like the marks for that, for example, I have no idea like my progress and whether I'm going to pass or not because my quiz marks were not very great.
Yeah, but you have 50% on the group projects. You have 30% on the final exam. So you've done the group project already,
Yeah.
and then try your best to perform well in the final exam. That's the best thing you can do at the moment, right?
Okay. Okay, thanks.
No worries, no worries. Any other questions?
No, that's it.
Okay, okay, cool. Thanks. So you don't have to, Anthony, you don't have to wait here. I'm doing the record. Then I will upload the video after this consultation. So you don't have to wait there.
Yeah. Okay. I just also want to listen to other questions.
Yeah. This is what I mean. So I'm doing the record, and then I'm going to upload the video later. Then you can like rewatch the video and to see what others ask to save your time. I mean, if you want to be here, that's totally fine. But this is what I mean. Yeah.
Okay. Yeah.
Yeah.
You know the camera matrix, the 4x4 one?
Camera matrix. Camera projection matrix.
Yep. The 4x4.
That's 3x4.
Oh, that's what I meant. Yes.
Yeah.
Yes.
The camera the coordinate transformation matrix is 4x4, but the camera projection matrix is 3x4.
Okay, I've got my notes confused.
Yeah.
Well, I had a question about why it has the fourth column. I guess maybe show my rustiness with matrices, but why does it actually need the fourth column, where the one that's all zero?
Fourth column. So are you referring to any like lecture notes or something? Then we can talk about that.
I can't find it in the lecture. I'm just looking at my notes in my book.
Okay, yeah, sure. So you mean why you have the last column?
Yeah, so you know how you got the first column is fx in the first row, the next column is fy in the second row, the third column is px first row, py second row, and 1 third row, and then the next column is all zero.
Yeah, that's a very good question. So it is all zero. It is all zero because you do have the global transformation.
So
when you have global transmission, the last column is not zero.
Okay, so that last column is for.
What are we talking about? So I think it will be a little bit complicated. So let me find the. To ensure we are talking about the same thing, let me find the lecture note, and then I will share the screen, and then we can start from there.
Okay, sounds good.
Okay, wait a minute. Where is it? Yep. I think he should be the one. Wait a minute. Let me share the screen. Where is it? Share screen. Yep, there we go. So you can see the screen now, right?
Yeah, that's the one.
Yep. So is that what you're talking about?
Yep, that's the one.
Okay, okay. So why he? Let me try to. Can you see my mouse?
Yeah.
Okay, that's great. So why this column is 0 is because this is a central projection with a principal offset. So why we are using the matrix format is more for the general formulation. So if you come back to here, then although this is 0, but because the x is in the global column frame, then we have to perform this 4x4 coordinate transformation, right?
Yep.
And then combining this into here, then you can see the last column is the Manus translation or Manus camera center.
Okay.
Yeah, so that's the difference. That's the difference. That's why we want to use this matrix formulation, because it's more suitable for the general case. Yeah, that's a very good question. I think when I learned about this kind of camera geometry, and I asked the same question as well. Yeah.
Okay. Cool. I also saw something. I was just doing some extra research on it, and I read something that in the 4x4, so that's with the rotation, I guess.
Yeah, so this is 4x4, and the rotation matrix R is 3x3. So I'm explaining about the dimension here, maybe here. So the K is the camera projection matrix, which is by 3x3, right?
Yep.
And the rotation matrix here is 3x3 as well. It's a 3D rotation matrix. It's 3x3, and this indent. So this matrix. How can I do? Okay, so this matrix is a 3x4, with the first three columns as the identity 3x3 identity matrix.
Yep.
And the last column is minus C or minus T, which is minus the translation of the camera.
Which is a 1x3, I take it.
1x3, yes, and don't forget it's a minus. It's minus here.
Oh yeah.
Yeah, and then this capital X is 4x1, which is a 3D point, but in homogeneous coordinates, which means x, y, z at 1.
1. Yeah.
Yeah.
Okay. Okay. Yeah, that makes a lot of sense now. I think I just got. I was getting a little bit confused on the triple dots.
Yeah, sorry about that. This is This is some kind of like separating the matrix. This matrix is a 3x4.
Yeah.
With the first 3x3 identity, and the last column is 3x1. Yeah.
Okay, that makes a lot of sense. Yep. That helps a lot. Thanks, Liang.
No worries. All good.
Yeah.
Okay. Cool.
All right. I'll see you later, I think.
Yeah. Sure. I'll be here until 12. So you don't have to wait here. I'm doing this recording. But if you have questions, just come back.
Okay, sweet. Thank you very much.
No worries. All right. See you.